All right, let's do 14. This is a favorite problem of mine because of Karch Karai being inspirational to me personally. I played volleyball for a little while, and he was very popular at that time back then. In any case, I was going to show a quick little Karch Karai move. This is Karch Karai at the end of his career. Uh, Pretty impressive jumper there. In any case, I thought it's also appropriate since we've got the sack going on right now, and we'll take a look at Karch Karai. So vertical leap of 48 inches. And then I just ask a couple questions. A, how long is he in the air? And then B, what is his velocity just before he lands on the ground? Um, so his vertical leap of 48 inches isn't going to work for us because our acceleration is negative 10 meters per second squared. I think it's probably best if we go ahead and convert that. So using the 1 inch equals 2.54 centimeters, we convert that into meters. In any case, let's say we were going to do the problem and we decided to have this be our initial condition here and this be our final place here, knowing that it goes up and comes back down. So the displacement is going to be 0. Okay, we have the acceleration of down of negative 10 meters per second squared. And the only other information we have, which is how high he goes, which ends up being 1.22 meters, doesn't help us because the displacement is 0. We end up with 3 question marks. And I went ahead and threw this on here because I think it's important for you to realize that when you get stuck, it's not a big deal. So here's 3 question marks, and that means, you know what, we can't do this problem because we need 3 items of the 5. So we stop and we try something else. And what we're going to do this time is we're going to go ahead and put the beginning at the bottom and we'll put the end at the top and rethink the problem. Okay? And when we rethink this problem, we realize that the displacement is now known. It's going to be positive 1.22 meters because it's going up, so that's positive. And then the acceleration is still negative 10, and that's going down. But now we have this new piece of information, which is the final velocity being 0 at the top. So now that we have 3 pieces of information, we can go ahead and solve for the other 2 we don't know. I went ahead and went with VF squared and the VI squared equation here. Be careful here with your negatives. The A is a negative 10, and the displacement's a positive 1.22. And so you end up getting a VI, taking a square root. Be careful deciding whether we needed a positive or negative. We need the positive because obviously he's going upwards at the start, and that gave us initial velocity as he leaves the ground. Then we can get the time in the air quite easily using the first equation there, and it ends up being about half a second, 0.494. Now this is only on the way up, and since he ends at the same level where he took off, we can just double that time. So he's in the air for about 0.988 seconds, which is amazing hang time. And as he comes back down, he's going to have the same final velocity on the way down, so we can use the 4.94 again, but it'll be negative because he's headed downward. And that is the Karch Karai problem. Hope that helped a little bit.